Expected value problems in probability. The expected value, E of x, represents what we would expect to happen to something in the long run, is the theoretical value or theoretical probability of what we think should happen. For example, if we flip a coin 10 times, and it's a fair coin, how many heads would you expect to get out of 10? Well, the expected value is going to be 5 heads. Does that mean we will always get exactly 5 heads out of 10? No, because the experimental value could be different than the expected value. But in the long run, if we flipped the coin many times, let's say we flipped it 1,000,000 times, we would expect to get 500,000 heads. Would we get exactly 500,000? Not necessarily, but it would probably be close to 500,000. When we flipped it 10 times, 7 heads could happen, not unusual. But if we flipped it 1,000,000 times, getting 700,000 heads would be pretty unusual. Because in the long run, when we do something a whole lot of times, the experimental value should start to match or get very close to the expected value. Now, we're not going to use that idea to do the next problems, but I just wanted you to understand what an expected value is. Let's take a look at our first example, which comes from life insurance. A life insurance policy costing $380 pays $250,000 in the event someone dies. The probability an 18-year-old will survive the year is 0.9991. What is the expected value to the insurance company? Let's set up an equation. E of x, our expected value, is going to be the following. It's going to be how much the insurance company expects to keep minus how much the insurance company expects to lose. So how much do they expect to keep? Well, every single person who buys a policy has to pay $380. And the insurance company will keep all of that money, 0.9991 out of 1 times. That is about 99.91% of the time, they will keep all $380. Now, how much are they going to lose? Well, if the person does not survive, they will pay out $250,000. Now, I'm going to leave a little bit of space. We'll see how in just a bit. Now, how often do they lose the money? Will they lose it the complement of my 0.9991, or 1 minus 0.9991, that is. They're going to lose the money 0.0009 times, or roughly 9 times out of 10,000. Now, how much money do they lose? Well, they pay out $250,000, yes, but everybody has to pay $380 to get a policy. So they lose $250,000 minus the $380. It's a very small difference, but it is something that we need to be aware of. And in total, what is the expected value to the insurance company? So if we type all these numbers into our calculator, we get $155. So out of every $380, the insurance company expects to keep 155 of it. Now let's take a look at an example from casinos or gambling. In this example, a person places a $5 bet on the number 19 on a roulette wheel and has a 1 in 38 chance of winning. If the player wins, he gets $170. If he loses, the casino keeps the money. What is the expected value to the casino? We will set it up again. The expected value is how much the casino expects to keep minus how much the casino expects to lose. Notice that they're going to get $5 and they're going to keep it 37 out of 38 times. That is, they'll keep all of it 37 out of 38 times. Because they lose the money or have to pay out 1 out of every 38 times. Well, how much money do they have to pay out? Well, they pay out 170, but they only lose 165 because they already got the original 5 and they're just going to pay back 170, so the total loss is $165, 1 out of every 38 times. So the expected value to the casino is about 53 cents on a $5 bet. Let's do one last example from investments. Suppose a person invests $10,000 in the stock market. There is a 30% chance that the stocks will increase by 10%. There is a 50% chance the stocks will increase by 5%, and a 20% chance the stocks will decrease in value by 3%. What is the expected value of the stocks at the end of the year? Well, let's worry about the value of the stocks after we figure out what's the expected percent gain or decrease at the end of the year. So I expect, based on this information, that there is a 30% chance of what? Well, of gaining 10%. And then there is a 50% chance of gaining 5%. And then there's a 20% chance of losing 3%. Notice the negative sign indicating a loss. And so if I calculate all of this, I get an expected value of 0.049. What does that mean? I expect to gain 4.9%. That is my expected value. So now we can answer the question, what is the expected value of the stocks at the end of the year? Well, it's 4.9% above, I'll put expected value of stocks here, 4.9% above what we started with, or $10,490.